All right, let's see if we can do this awesome math here. Logs of exponentials and inverses. I wouldn't really call this notes. I would really call this, I would call it an overview because I'm assuming that you guys know already a little bit about logs. I'm assuming you know, yeah, that's fine. I'm assuming you know the properties of it. And if you don't, I'm going to go ahead and write them here. So log of x times y is the same thing as log x plus log y. And log of the quotient x over y is the same thing as log x minus log y. And if I have something like log of x to the power y, that is y log x. And all three of these rules, this is called the product rule. This is called quotient. And this is called power. So if you Google that, that's what it's called. Let's see, what else do we got to know about that? If you want to know where these rules come from, logs and inverses are exponential. Logs and exponential functions are inverses of each other, guys. So these rules really just come from your power rules, your exponential rules. That's where it comes from. Hey, look, I see Grandpa in the background. Sorry, guys. I love animals. So anytime I see a dog or a cat, every time I go walking in the park, not that I go walking often, but I always want to pet every single dog I see. Do you guys have that same problem, or is that just a me problem? Yeah, okay. I want to farm, guys, and I'm sorry if I'm giving you guys TMI, but I want to farm with a whole bunch of animals, but none of these animals will ever be slaughtered or anything ever. I want some pigs, I want some cows, I want some dogs, I want some cats, I want some goats, and they're all going to live happily on the farm forever, and they're never going to die because they're going to be my animals. Anyways, let's continue with this here. So yeah, these rules come from your laws of exponents. We'll have a lesson maybe one day if I feel that we're really weak on why this comes, but they come from the laws of exponents. Let's see, what else? Oh, side note. This is called log because it says log, and this is called natural log. I do not know why they put the L in the front, and maybe having something to do with this was all done back in the day in Latin and stuff like that. So that's called a natural log. That's called a log. They are brother and sister. So the same properties that apply to log apply to natural log. Same thing. Cool or not cool? Okay. One last side note. Natural log x is the same thing as a log with the base of e. X. So this is how they're connected. ln is natural log and log is log. All right, so let's talk about these questions here. So these are the easy ones. You might see a question like this and like maybe some type of like army recruitment or something like that, like see your math aptitude. So this is pretty basic. Turn this into an exponential function. 2 to the power x equals 256. And then once you see that, hopefully you can do this without a calculator. So you say, let's see, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, 32 times 2 is 64, 64 times 2 is 128, 128 times 2 is 256. So there it is, x equals 8. That's how we would do it. Chavez, what did you do? 2, 4, 8, 16, 32, 64, 128, 256. X equals 1, semicolon, x equals 2, semicolon, x equals 3, semicolon, x equals 4, semicolon. And you guys get the job. Or I hope we get it. X equals 8. Sorry if I'm going too fast. I'm going to try to slow down, guys. I hope, and this is a side note, another side note. Man, this is all filled with a whole bunch of side notes. Notice these numbers. Have you seen them anywhere before? Have you ever seen these numbers in some type of electronic products? 512, 1024. Your iPhones, guys, the memory. 2, 4, 8, 16, 32, 64, 128, 256, 512. That's because all electronic devices are binary. And binary means 2, 0, or 1. So because it's a binary product, if you add an extra bit, you go up in memory. So every time there's another bit, it goes up. Anytime for those of you that are doing like web encryption, 256-bit web encryption, well, there it is. These numbers come out all the time in electronics, guys. So hopefully you guys are seeing what's up. All right. Is there another way to solve this? Yes. Let me show you the other way to solve it, guys. Look at example 2. Example 2 is not a pretty number. So what I would do first, and let me go ahead and change the color on this one because there's red all over the place. Log base 5 of 17 equals x. And then I would turn this into an exponential. 5 to the power x equals 17. And this one's not a pretty number. So this one, I would use your log properties to get x by itself. So I'm going to use the power property. See, because I want to bring down that power. So now I'm going to go back to my red, put ln. Why didn't I not use log? Because I wanted to use ln because it's one letter less. Not that it matters, right? They're both the same. Bring the x down. X ln of 5 equals ln of 17. Sorry, guys. I'm thinking about the answer that I just gave you, and it's like the worst answer in the world. I'm going to get x by itself. So to get x by itself, I'm just going to divide by ln of 5. And there it is. That's my answer. I would leave it alone. If you are adamant about wanting a number, no big deal. Let me show you my calculator. I'm going to get my calculator out. Come on, buddy. I'm going to show a TI-83, guys, or TI-84, sorry. I'm showing a TI-84 because that's I have an emulator for that, and I can bring that up really fast. So here's my screen showing my TI-84. So here's my TI-84, and I'm just gonna type that in. So how do I type it into a TI-84? I push second y equals, I push enter, and this will get me my little fraction feature. And I'm just gonna type ln of 17 in the top, close it, divided by ln of 5 in the bottom. And if you're wondering why I don't use a TI Inspire, I just don't like the drop-down menu on the Inspire. But the Inspire is a good calculator. I have it in my backpack right now.
Chav.
Yes, ma'am.
Can you explain how you moved the x as an exponent to be in the front?
Yes. Yes, of course, miss. I'd love to explain. So anytime I have something that looks like this, let's put b to the power a, I can bring that down, a ln of b. And the reason I can bring that down is because it's a property of logarithms. So the ln is what I typed in there to be able to bring that x down. So anytime you want an exponent to come down, insert ln. Does that make sense? Okay, repeat what I said, miss, just so I can make sure.
Because it's a property of the logs, so it only works if you put the natural log in front.
Yeah, perfect. I could also put the word log in there too, but I chose ln because why not? But you could have also used log as well. Anytime you have an exponent and you want to bring it down, use ln. Always. Always, always, always. All right, these are properties. I will give you these properties, guys. I've seen different names. Change of base property is probably the most, the best name that it's known for, but it's not a change of base for this one, but that's fine. We included it in there anyways. Change of base property. If you need it, I will give you these equations. At the moment, I'm not seeing any issue where I'm going to need them. All right, so let's go to example 3. And all right, so I have 7 to the power 3x equals 983. And I'm trying to solve for x. So Ms. Cruz, do you want to help me out? How do I bring this 3x down? Do I just bring it down, or do I got to insert something?
It's going to turn into 3x natural log times 7.
Yes, you're right. And the natural log of 7. 7's the argument, but you're right. Put an ln on both. Whatever you do to one, you do to the other. Good job, miss. When you do that, that 3x comes down. So just like Cruz said, 3x natural log of 7, that's the argument, equals natural log of 983. And now what I want to get x by itself. So I'm just going to divide that whole deal by 3 ln of 7. Whatever you do to one, you do to the other, right? So my x value is ln of 983 divided by 3 ln of 7. Leave it alone. If you really want a number, which honestly, I don't really want a number, but I'm going to go ahead and show you. I would leave it alone. That's the best answer in my opinion. If you were taking a calculus AP exam, you would leave it like that. But here's my calculator, and I'm going to type it in. I'm going to do the little fraction feature. Alpha y equals, I push enter. And then on the top, I just type ln 983. In the bottom, I type 3ln7, 3ln7, and I push enter. And there it is, 1.180 if it's rounded. I mean, if it's truncated. Well, actually rounded and truncated, right? 1.180. Done. How do we feel, guys? Do we have any parents looking at this awesome notes? How do your parents feel? Ask them. See if they're learning. Okay, well, okay, I'll stop, guys. I'll stop. But if your parents do want to learn math, yeah, come in. I welcome them. Come on in. What's up?
Could you go back up real quick? Sorry.
Yeah, no problem, miss.
Okay, thank you.
Okay, so check it out. Oh, I guess some really quick. I'll get some more side notes. Whenever you hear me say the word argument means what's inside the parentheses. Your logs always have an argument. The argument must be greater than 0, must be a positive number. Greater than 0. So when you were in Algebra 1 and Algebra 2, and your algebra teacher told you what is the domain of this expression of y equals ln x, the domain is x greater than 0. If you don't remember, that graph looks like this, where that coordinate is 1, 0. All right, so let's see if we can use our properties to figure this out. So it says solve the equation log base 2 of x minus 1 plus log base 2 of x minus 3 equals 3. And it says to check my solutions. Like, all right, I'll check my solutions, I guess. So because I have the same base with a plus in the middle, I can create one log, guys. Log base 2, giant parenthesis, x minus 1, close, open, x minus 3, close, close, equals 3. So get there. And then from here, guys, all I'm going to do is create an exponential function. So 2 to the third power equals that on the inside. 2 to the third power equals x minus 1, x minus 3. Why does that work? Because logs and exponentials are inverses of each other. So I guess I'll make a side note. Side note, log of log base b of a is equal to x is the same thing as b to the power x equals a. Logs and exponentials are inverses of each other. And we have a whole bunch of log notes for this, side notes for this. All right, from there, guys, I'm just going to do algebra. 2 to the third power is 8. 8 equals, and I'm just going to FOIL this out. FOIL or distribute. X times x, x squared. X times negative 3, that's negative 3x. Negative 1 times x, that's negative x. Combine like terms, minus 4x. Negative 1 times negative 3, positive 3. Move the 8 to the other side. 0 equals x squared minus 4x minus 5. What did I do? Travis, what did you do? Minus 8, minus 8. Trying to be better with my notes, guys. I read all your comments. So when you guys tell me, one of you said, please show more details when writing notes because you go from one to the other and sometimes I don't know what you did. Well, look, now I remembered that, miss, just for you. And look, check it out, minus 8, minus 8. I showed detail. So trust me, guys, every time you guys give me feedback, I take it to heart and I will try my best to do what I can. So give me more feedback. All right, anyways, continuing. From there, now that I have x squared minus 4x minus 5, I'm going to factor these dudes out, guys. So look, two numbers that when I multiply give me negative 5, but when I add them up, give me negative 4. Can you think of those two numbers? X. When I multiply, give me -5, but when I add them up, give me -4. What two numbers am I thinking about?
+1 and -5.
That's right. That's right, miss. -5 times 1 is -5. -5 plus 1 is -4. And now I just answer the question, right? So the only way this statement will be true is if x equals 5. 5 minus 5 is 0. 0 times anything is 0. Or if x equals -1. -1 plus 1 is 0. 0 times anything is 0. Now you got to check it. So now we're going to check. Check answers. And Delta Math has you typing it into the calculator to verify that it gives you a 3. I'm not going to do that. I'm just going to check that the argument is positive. So if I plug in a 5 in here, let's see, 5 minus 1. Yep, and 5 minus 3, 5 checks out, check mark. If I plug in a -1, what am I doing? I'm plugging it in here. -1 minus 1, that's a -2. And I just have in here that it has to be greater than 0. So nope, that it cannot be. That one's done. So the only answer is 5. What's up, Miss Cruz? I saw your hand up.
Why wasn't it like x plus 5 and x minus 1?
Oh, that's a good question, miss. Why wasn't it, so don't write this down, just listen. So why wasn't it x plus 5, x minus 1? If I go this way, when I FOIL or distribute, I would have gone x squared plus 4x minus 5. And I don't have a plus 4x, I have a minus 4x. You know what I mean? So the trick to this is just look at these numbers here and say, okay, that number and that number, when I add them up, does it give me a -4? And it does. -5 plus 1 does give you a -4. Okay, now there are going to be other harder ones on Delta Math where the A is not a 1. When you get to there, if you are having issues with how to factor for A does not equal 1, let me know. Yes, you can type it into your TI Inspire, that's fine, to give you the factors. But I would like for you guys to be able to do that without a calculator. All right, guys, is it okay if I go to the next one? All right, perfect. Example 5, and don't worry, we're almost done. I know that maybe this might be torturous for some of you because you already know it. So if you already know it, you're like, man, I already know this. Why do I got to be here? So I apologize, guys. So what I'm doing right now, I'm using a property. I'm using the quotient property. So why did I do that? Well, I have a minus sign there. So let me go ahead and write the property that I just used. I use this property. Log A minus log B is equal to log A over B. And that property is called the quotient rule. Quotient rule for logs. All right, and of course, all that equals this number. So there it is. Are we okay with the first step? All right, perfect. So now what I do, guys, I'm just going to turn this into an exponential. So I'm just going to go 2 to the power 3 equals that expression. 2 to the power 3 equals x squared plus 7 over 2x plus 3. And Chavez, you must really like 2 to the power 3 a lot. No, not necessarily that I like it. It's just, you know, because I know that you're seeing 2 to the power 3 over here as well. It's just that it's something that you can calculate really simple that everyone understands that we don't need a calculator for. So 2 to the power 3 is 8. So I'm going to rewrite it as 8 over x squared plus 7 over 2x plus 3. So the whole point here is I'm trying to solve for x values. So the only way to get an x values by itself is if I multiply this fraction by the denominator. Chavez, I don't understand you, Chavez. Let me tell you why, guys. When you do this, you will have a quadratic expression. You will no longer have a rational expression. So when you do this, you will have a quadratic expression. So let's see, 8 times 2x. That is 16x. 8 times 3, that is 24, equals x squared plus 7. Travis, I don't see quadratic. I see quadratic on the right and linear on the left. I don't know. Maybe you're just trying to write stuff down and I'm going too fast. So I'm going to slow down, guys. All right. Move everything that you have on the left-hand side to the right. And you will get a quadratic expression that can be factored out, or at least I hope. We'll figure it out right now. So move this to the right. When you do that, it's going to turn negative. And subtract 24 from 7, so minus 24. So 0 equals x squared minus 16x. What's the difference between 24 and 7? 17? That took too long. Sorry, guys. 17. And now, let's see. All right, Miss Cruz, you're going to help me out on this one. And I'm sorry, don't worry. I'm not going to pick on you anymore after this. Give me two numbers, and it's okay, take your time, that when you multiply give you negative 17, but when you add them, give you negative 16. And it's okay if you're wrong, miss. We're all here together.
Negative 17 and positive 1.
Absolutely correct. Good job. You're so smart, miss. Don't ever let anyone stop you. You can do this. Now, the honest truth, guys, and this is the honest truth. I think you guys are doing pretty awesome because look, you're doing all this through a pandemic, through virtual. Like I just got the chills right now. Thank you guys for being so awesome and for always being able to participate. And all right, I'm gonna stop before we start, or before I start crying. Anyways, so here we go, guys. I'm just gonna solve for x. X equals, I don't know why I wrote 0 equals when I can already solve right here. X equals 17 and x equals negative 1. Now I gotta test them, right? So I gotta see if I get a positive argument. So I just come up here and let's see, 17 squared plus 7. Okay, the 17 is gonna work for sure because that's overkill. 17 squared plus 7, that's a positive number. 2 times 17, double that, plus 3, positive number. What about the negative 1? So negative 1 squared is 1. 1 plus 7, that's still positive. Negative 2 plus 3, that's a positive 1. Yep, they both work. So on this one, both of them work. Cool, guys?
For the last one that we did, for number 4, can you explain why it was just number 5 that worked?
Okay, which one? The example 4 or example 5?
The one with x equals 5 and x equals negative 1. Or like,
oh, yeah.
What you said with the graph.
Yeah, all I did was like explain like how I got that the x equals 5 is the answer. I know that the x equals 5 is the answer because all I was doing is checking to see if I have a positive argument. I know it would work, by the way, if I plug in a 5 and you'll get 3, but we'll check it right now. So if I plug in a 5 in here, all I'm doing is, do I get a positive expression or a positive number? 5 minus 1 is 4. 5 minus 3 is 2. And yes, all I did was check that I get positive numbers, and I do. But another way you can check it, if you don't like that, because maybe you're like Chavez, but I want to see if it equals 3. So can you see my calculator right there? So one way I can check it is I can just literally type this in. So here we go. I'm going to push math on this. And the log base is under right here, letter A on this one. Log base, and I push the base of 2. And then on the inside, I'm going to push 5 minus 1. Or you can put 4 if you want. And then on the outside, I'm going to put plus math log base. And then the 2 again. And then you can go 5 minus 3. And then check it out. It equals 3. Cool, right? Did I answer your question? I don't know if I understood your question correctly. You good? Okay. Sorry, miss. All right. Let's see. What do we got next? Do we have any questions on this one, miss? Example 5? Okay, awesome. All right, guys, look at example 6. It's more of the same, but we're just trying to expose you guys to more experiences here. This one I stole from UH. This was a UH question. Was this a UH question? No, this one was not a UH question. Well, maybe it was. I don't remember it. All right, here we go. So solve the logarithmic, same deal. I'm going to use the product rule. So natural log, giant parenthesis, x plus 3, close, open, x plus 5, close, close, equals 0. And then it looks like we're kind of stuck, and we're not really stuck, but it looks like we're stuck. We're gonna use, here's a side note, natural log x is equivalent to log base e of x. So I'm gonna transfer this into a log. So I'm using this bullet here, or that bullet there. So I'll transfer the natural log into just a log. So log base e, and then just leave the inside alone, right? X plus 3 close, open, x plus 5 close, equals 0. Now, in case you're wondering, all right, Chavez, slow down, and why did you do that? I have no idea why you did that. The reason why I did that, guys, is because the whole idea about this is I want to be able to translate this into an exponential so I can solve for x. Are we cool? You'll see what I mean right now. So, make this into an exponential. E to the 0 equals that expression. E to the 0 equals that expression. Like, oh, okay, now I get it, Travis. Anything raised to the 0, guys, is always going to be 1. Perfect. 1 equals, okay. And then I'm just going to distribute this guy, or this dude here. X times x is x squared, plus x times 5 is 5x, and then 3 times x is 3x, and together it is 8x, plus, and then 5 times 3 is 15. There it is. I'm going to move that 1 to the right, minus 1, minus 1. 0 equals x squared plus 8x plus 14. And then I start thinking, is this factorable? 14 times 1, 7 and 2, 4. Nope, it's not factorable. Is there another way to solve this without factoring? Remember, what did your algebra teacher teach you?
Did you do the quadratic formula?
Perfecto, yes, absolutely. You can use the quadratic formula, guys. So I'm just going to use the quadratic formula. A is 1, B is 8, C is 14. This dude comes out all the time in like several subjects in physics and finance and a whole bunch of other stuff. All right, so here we go. X equals negative 8 plus minus square root 8 squared minus 4 times 1 times 14 all over 2 times 1. I'm going to take my calculator. You're going to get 2 answers. So I'll wait for you guys to catch up here. When did I close my calculator? Sorry guys. We're going to have to take a 5-second time out here because I don't remember closing my calculator, but it's closed. Okay, here's my calculator again. So I take my calculator, and in the TI-84, the way you get the little fraction thingy, you got to push alpha and y equals, and you push enter, and there it is. And I'm just going to do the plus one first. Negative 8 plus square root of 8 squared minus 4 times 1 times 14. All this is divided by 2. And push enter. All right, guys, here comes a skill that we want to get really good. If you have a TI Inspire, look for the buttons called STO. So I'm going to store this number into a register in the calculator. We're in the 21st century. You guys should be super beast at electronics. Let's store this into a calculator, into a register called A. So how do I store it? Between 1 and 4, it says STO. If you have an Inspire, look for the STO button. And then I'm going to store that into A. So I'm just going to push A, or alpha A, enter. So now every time I push A, it's going to be that number. Negative 2.5857 if it's truncated. Negative 2.5857. Negative 2.5857. All right, I'm gonna show you guys how to do it again. So here it is. Here's my calculator. I'm gonna do the same thing again, but instead of plus, I'm gonna do a minus. And I just like to go down the alphabet. So I'm gonna push enter. And I'm gonna change that plus to a minus. I'm gonna push enter again. And I get negative 5.4142. I'm going to store that to B. Store alpha B. So there I am at B, and that's how you do it, guys. On the TI Inspire, it's the same thing. Look for the STO button. You might have to push like blue, shift blue or something. STO, and now it's stored as B from now on in my calculator. So negative 5.4142, negative 5.4142. There's a reason why I did that. All right, now we're gonna check it. Now check. I don't think you need a calculator to check it. Let's look at it. Looking at it, guys. I want you guys to focus on this one here. Negative 5.4142. If I plug in a negative 5.4142, this expression will be negative. See, look, if I plug in a negative 5.4142 for that plus 5, it's going to be a negative. Can I have a negative expression or a negative argument? No, you can't. So it can't be this one. So if I want you guys to see that if I type ln of b plus 3, because right now I have it saved as b. So there it is. I have it saved as b, negative 5.41. So look, ln alpha b plus 3, close it, plus ln alpha b plus 5. It's probably going to tell me it's a complex answer or something like that. Non-real answer. I mean, there is an answer. It's complex, and it does mean something, but I'll let your professors take care of that. Yeah, it doesn't work. It has to be a positive argument. Now let's try A. Let's see if we get a 0 here. So I'm going to push enter. Now I'm just going to scroll up, and I'm going to change that B to an A. Change the B. Change the B. And look at that, guys. Yay, we got 0. I thought that was cool. You guys don't look impressed. You guys are like, okay. That's fine, guys. Pretty cool stuff. I thought that was pretty legit. Okay. I'll probably edit this part out of the video because I don't want any university to come at me. This question, let me go ahead and be full disclosure for you. And I'm not going to give, I don't think she would mind, but I still want to keep that information confidential. This question is coming from a math placement exam for a university, a very prestigious university. So she took a math placement exam at a very, very well-recognized university, and then she got back her score. And on that, it said that she missed this exact question. And I looked at her and I saw this and I'm like, Miss, you know how to do this question? And she's like, I know that I've seen it before, but I just couldn't do it. And it was a no calculator. It was a no calculator question. So I'm bringing this up to you guys right now to let you guys know that you guys know how to do this question. You guys just maybe haven't been exposed to it in Algebra 1 and Algebra 2. And really, it's like an Algebra 2 question. But let's go ahead and take care of it right now so you can see that you know how to do it. So don't ever be intimidated by these type of questions, guys. So remember, you don't have a calculator, no calculator. And you get this type of question. And it's free response for a math placement exam. Oh, man, how do I do it? Let's see. You're looking at it, and doesn't it look kind of like, and I'm going to put it in quotes, doesn't it look like a quadratic? And I don't know, maybe some of you guys are saying, no, I see an exponential. I don't see any quadratic. That's you guys, by the way. I'm not saying you guys have deep voices, but that was me being you. Anyways, so here we go. What I mean by quadratic, guys, doesn't it look like this? Doesn't it look something like that? Kind of. Or, okay, maybe you guys don't like X's. Doesn't it look like this? You guys like happy faces? You guys, here's happy faces in case you guys like happy faces. Okay, I can see some of you guys are haters and you guys don't like happy faces. All right, I'll change it up to triangles because I can see the haters. You haters. Here you go. Here are some triangles. So now everyone's pleased. The haters are pleased and the happy face people are pleased. All right, there we go. Doesn't it look like that, Chavez? No, I still don't see it. I still don't see it, Chavez. Let me make it look like that, guys. E to the x squared. There you go. Now does it look like that? Oh, no, Miss. Yeah, no, there was people hating on the happy faces. I can see in this secondary screen, that's how I know they were hating. They were like this. I don't know if you guys can see my face, but that's how they were. They were like this. Either they were hating or they weren't looking at it, or who knows, maybe they're just done with math and they're like, just do the question so I can take care of my delta math. All right, here you go, guys. Let me go ahead and take care of that. So it looks like that. So see, there it is. It looks exactly like that, guys. So if it looks like that, I can use my quadratic equation. I can also factor it out if you see it. But I think the fact that there's an e to the x, you guys get scared and like, oh, I don't want to factor. So let's go ahead and use our quadratic equation. So if I wanted to solve for happy face or triangle, that's just this. Or, you know, triangle equals that as well. So that's what I'm going to do, guys. I'm just going to go e to the x equals, and then what is a? A is 1. What is b? B is -3. And what is c? C is 2. So I'm going to go e to the x is equal to opposite b, so 3, plus minus square root -3 squared. I guess you don't need that negative when you're squaring because it's going to be positive anyways. Minus 4 times 1 times 2, all over 2 times 1. I don't know, Chavez. Those numbers are pretty big. I don't think I can do it without a calculator. Yes, you can, guys. You just need to slow down a little bit and then just look at it and be like, oh, yeah, I can tackle those. So let's see. Oh, man, where'd it go? All right, so here we go. E to the x equals 3 plus minus square root. -3 squared is 9. 4 times 1 times 2, that's 8. See? 3 plus minus square root. I'm trying to show as much detail as I can, guys. And the square root of 1 is just 1. No, on a normal exam, or if I'm doing the work here by myself, I probably wouldn't show all this detail. So I think it's okay, or I think it's fine if you skip some of that detail. But if you want to show the detail, that's fine. All right, here are my two solutions. E to the x. I'm going to do the plus 1 first. 3 plus 1 divided by 2. 3 plus 1 is 4. So 4 divided by 2, which is 2. Get it like that for now. And then don't worry, in a little bit, we'll finish it. Let's do the other one. E to the x. So instead of plus, I'm going to do minus. 3 minus 1 divided by 2. Let's see. 3 minus 1 is 2. And 2 divided by 2 is 1. Don't worry, guys. We're almost done. This one's the easier one if you recognize it. So let's do that one real quick. So what I have is this. E to the x is equal to 1. Think about it for a little bit. What x value can I insert in there that I will get a 1 immediately? There's only one number. Yeah, perfect. Perfect, 0. Yeah. Way to go, guys. So that one's the easiest one. What about this one, Chavez? All right, let's do that one. E to the x equals 2. I want to bring the x down. So if I want to bring the x down, what am I going to put in front of that e, Miss Cruz? No, I thought I wasn't going to pick on you. My bad, miss. Just this last time. No more questions after this.
Natural log.
That's right. Good job. Natural log. Bring that x down. X. Oh, I don't want you guys to think that that's that. That is that guy. X ln of e equals ln of 2. And I don't remember if I gave you guys a side note or not, but hopefully we remember from algebra. So I guess another side note here, ln of e is equal to 1. So ln of e is equal to 1. So now that means that I can just write x equals ln of 2. And there's the answer that the university wanted. That one and this one. And those two check out. They will work. And yeah, that question was on a placement exam for a prestigious university. A very prestigious university.